Good evening, good afternoon, or good morning. We are from Team Foxtrot. Our project is Waste to Energy Power Plant. I am Brian Irawan, 1691936 and here I have also my colleagues Safira Nastaranta, 1691935 and Abdul Hakim Halim Nagabonur, 1691938. Next. So Um, the problem that we have in this project is that is to solve Bandung's current uh, over trash problem. We have so little landfills for for a lot of excess trash, and the current solution we have taken a look at the governmental decision and uh, the market decision says that in 2007 waste management companies like Parompong emerges, and in 2020, which is the current year, the West Java government partnered up with Plastic Energy, um, a company from the United Kingdoms, uh, which converts plastic to usable fuels. Um, when we analyzed the problem, we found out that landfills are in shortage and there's not enough space in these landfills. So proven methods, however, we have found that proven methods indicate waste potential in being recycled into more useful products such as energy and quite possibly uh, graphene or industrial matter of many kinds. Next. So this is the design requirement of our project. It needs to be household friendly. It needs to be safe, of course. It needs to be mechanically simple, so maintenance is not a big hurdle. It needs to be effective at fulfilling the objectives, of course. It needs to be energy efficient. It needs to be applicable in the city of Bandung. Now we are demanded that it could decrease or convert solid waste into useful products, like what I've said before, diesel or industrial products. Uh, Another requirement, another demand actually, is for it to be an original design. It has to be space and cost efficient. It could utilize multiple types of waste materials, and it needs to create as least amount of possible of noise pollution. Now, what we wish from our prototype, our project, is that it could manage as much waste as possible. It is successful at achieving the objectives and demands. It is close to carbon neutral, meaning that it does not emit pollution. So it is quite eco-friendly. Next.
So before coming up with our final design, we have several alternative design. These are two of them. The first one converts plastic bottles into strings and ropes, and the third one, we use UV light to degrade plastic. Now, the first one is mechanically simple. However, it lacks in versatility and thus is not preferable to and is not and is like not that effective for Bandung's waste problem. And the third one, it is only a conceptual method, and therefore there aren't exactly any proven ways that such designs could really improve the degradation of plastic. So this is our chosen design. The principle is for it to be space efficient, aesthetically pleasing, and it's able to suit Bandung's terrain. So we have a few sketches here, and from those sketches, we constructed the 3D design. And just from the 3D design, our initial design, we have water tank, steam turbine, generator and combustion chambers as well. And we improved it from our sketch. We add like more detailed composition and also uh, make the components more clear. So this is our final design. Um, from our previous question and answer session, also criticism, we evaluated that we require several more better and more clear uh, design such that it explains the process of how uh, burning trash could result in electricity. So this machine, as stated before, is a machine that converts waste through the means of heating those waste and using the steam from those heat to construct and create and generate electricity. So our improvement from our previous 3D design is the addition of a condenser, compressor, and dry electrostatic precipitator, water pump, and also we improved our incinerator. We upscaled it to make it more efficient, and in terms of electricity generated and cost that is used, and also in terms of turbine, we've evaluated that we are going to use more commercial turbines for more cost efficient and also to locate it in landfills farther away from the residential areas.
Okay, so the device will work in this following mechanism. So the heat is going to use to boil the water inside the pipe, and then it will reach into a compressor, and then the compressor increases the pressure of the steam and flows it to the turbine, and then the turbine will rotate and also rotating the coil inside the generator, which magnet axis, and then the magnetic fields generates electricity, and then the steam was sent into a condenser through the water pump and back into the water pipes leading to the incinerator.
To add to my colleague's explanation, the waste product from the combustion, incinerator will also result in fly ash as well as smoke, which is why the smoke is going to be directed to the filter before it is released to the atmosphere for it to make like lesser damage, and the fly ash will be stored in the black container for further purposes of degrading it. Okay, next.
And by this mechanism, we hope that the device is eco-friendly. Okay, next. Okay, for the implementation, we hope that the device will be used in the small neighborhood so that everyone can contribute to use it. And then everyone can contribute to help the government and everyone to reduce the solid waste problem. First, we need to survey the region, what the needs and the condition of the region, so that we can finalize our design concept. And then we're going to explain to the community and other parties so they can contribute to the device. And then after we know the condition of the region and the circumstance of the society, we can finally build the design, test it, and ensure its safety and efficiency. And then we have a final test run. From them, we're gonna see if it still has a flaw. We could redo the design and fix it. And then in the other hand, when the final test result is great, we can finalize the arrangement for the electricity distribution. And then we also need to recruit some team to maintain the device and organize the procedure of waste disposal. And then we officially announce the utilization of the power plant.
So recalling the previous question and answer session, we have improved our implementation plan to incorporate NGOs, NPOs, um, and other parties in hope that through those parties we may have, in simpler terms, better communication with the civilians, and hope that the resulting discussion will be a one that benefits both parties. So this is our reflection and some of our resources. So to reflect, to increase the efficiency of the system, we added the steam condenser and modified the incinerator. And for social issues, we resolved by, aside from working with other parties, by moving the plant away from living quarters, and also to make it more modular, and also to possibly turn it into a syngas generator instead of waste to energy power plant, and others as well. So to respond, we have come to the end of the video presentation, and we're going to answer the questions given to us. So the first question is, please explain the working steps of your machine specifically. And the second question is, tell your literature study on the waste power plant, or WTE, and the mechanism, and what is the similarity and the difference with your product.
So to answer question one, our machine specifically works by combusting trash in a blast furnace. And a blast furnace works by um, flowing concentrated air into an enclosed system where the system is elongated upwards so that it will create high temperatures. This technology is not all that new. It can be found back in the medieval ages for smelting iron. You can see in this slide the very intricate way of, and as to how this machine works. First, of course, the trash is inserted into the blast furnace. Later on, air would be flowed inside the chamber. Afterwards, there would be an igniter that will render the trash flammable, and it will engulf it in flames. Afterwards, due to the design of the due to the blast furnace design concept, the temperatures up above in the very top portion of the machine would be very high. It would produce a really high temperature over there. But not only high temperatures, of course, there will be fly ash and smoke. Just as my colleagues said, smoke will be filtered out, fly ash would later then settle down, it will be collected into a bin down there. The heat generated on top of the blast furnace would turn water inside steam, uh, right there, yes. The water inside these tubes were from a water tank, of course, and steam would be redirected to a steam turbine. Now, the steam turbine is your commercial steam turbine, and of course, it is connected to your commercial electromagnetic generator. The steam, after it goes to the steam turbine, it will then condense back into a compressor and back into the water tank. That should be the specific ins and outs of our machine. If my colleagues would like to add.
I would like to add. So to add is that once the trash is added here, it will be periodically added slowly towards the incinerator here, and also that the waste product of the gas produced by burning these trashes, because it's not safe to directly release them to the atmosphere, it will go through this dry electrostatic precipitator right here, which will then go towards the atmosphere. And so we have basically three systems. The first one is the one where the water is heated into steam and it turns the turbine, which then powers the generator using electromagnetic conduction. And there is also the one that is regarding the waste product of gas. And there's the other one regarding the circulation of water and steam, which is this one. Once the steam goes here, it becomes condensed and then it goes to the water pump, and then it becomes water again, and then it becomes steam again. And so that's how the cycle continues. If there's any addition, please. Okay, so I would like to answer the second question just a little bit. Um, the standard waste power plant that we have researched is, of course, there are like numerous and they're also different in size. However, despite being similar in principle, we are different in design. It is shown by the size of our incinerator and like the form. Um, it's not just like a square. It took this form because it will like increase the heat and the efficiency, as well as to make it more efficient in heating the steam. And I yeah, if my other colleagues would like to add.
Um, I would like to add, and to answer the very last part of the second question, what is the similarity and difference with your product? Well, the similarity is that yes, although uh, WTE or a waste power plant is not all that new, and they pretty much work all the same, which is the similarities. Our design differs in that, well, mechanically, the shape of our incinerator is different. It is shaped very much like a cone, and this design takes from, again, what I've said previously in the first question, blast furnace for smelting iron. So it increases the efficiency of burning trash. Uh, that's all from me. If my colleagues would like to add anything else.
Maybe I would also like to add that the structure-wise and how the all these different components are placed also contributes towards our initial DRO, which is space efficient. And it can be seen that although they are um, apart in a way for like safety measures, they're also not so far apart to make it not space efficient. So we also think about the aspects of where to put it and how is it going to adjust with Bandung's um, land area.
All right, because there's nothing else to add, that would conclude our presentation. We would like to thank you for your attention, and good, have a good day.
Thank you.
Thank you.